Hey, what's going on, guys? Let's look at this problem right here. Here this question is asking a 6 microcoulomb charge is placed at the origin and a negative 4 microcoulomb charge is placed 2 meters to the right. What is the force on the first charge due to the presence of the second charge? And the second question is asking what is the force on the second charge due to the presence of the first charge? Okay, now in order to do this problem, let's go ahead and draw the diagram for this one. Here we have two different charges, like first is positive and the second one is negative, and also they are saying that this negative 4 is placed 2 meters right to the first one. And what is the first? Okay, and also the first one is placed in the origin. Okay, so these are the informations we know. Let's go ahead and draw that one. So first one, let's draw the graph first. So this is y-axis, this is the x-axis, and here we have a charge. This is going to be the positive because that's given right here. This is positive 6 microcoulomb. So this is our positive charge, that's at the origin. Okay, and this is 6 microcoulomb, and we have a negative charge that is placed 2 meters right to the first one. So from here to here we have a negative charge right here, and that is negative 4 microcoulomb, and the distance between them is 2 microcoulomb. And in order to calculate the force, we have to use this equation. F is equal to k q1 q2 over r square. We have the q1 value, let's call this one q1, and let's call this one q2. We have two charges, and also we have the distance between them. This one is 2 meter, not microcoulomb. Meter. So we have the distance between them, and also we have the k value, and we have to know what is the direction is, because when we express the final answer we have to put the direction also. Since these are opposite charges, they are going to attract each other, so the F1 force is going to be this one, force due to the first charge, that's going to be in this direction, and force due to the second charge, that's going to be in this direction. So since they are opposite charge, they are going to attract each other, so the directions are going to be toward the other one. Okay, now let's go ahead and calculate the charge. So first let's calculate the magnitude. F1 magnitude, I'm calculating the first force. Okay, we are calculating the force, right, not charge. Force is equivalent to k q1 over k q1 q2 over r square, k times q1 times q2 divided by r square, and k is what, 9 times 9, 10 to the power of 9, 9 times 10 to the power of 9 times the first charge, that is 6 microcoulomb, so 6 times 10 to the power of minus 6, and then the second one is negative 4 microcoulomb. I'm neglecting the negative sign because we are calculating the magnitude, so the negative doesn't matter. 4 times 10 to the power of negative 6 divided by the distance between them, 2 square, and if you calculate this one you are going to get 0.054 Newton in the x direction. Okay, now for the first one it's going to be positive because we can say this is equal to, okay, F1 is equal to 0.054 Newton in the x direction, because you can see the force is in the positive x direction, so this is positive x, and F2 is going to be same, since we are dealing with the same charges and the same distance, it's going to be the same magnitude, but the direction is going to be in the negative, because you can see this F2 is traveling in this direction, so we are going to have 0.054 Newton, but this is going to be negative x direction. And that's how we do this kind of problems. I hope this helps. Thanks for watching.